Hey, how are we doing, Regional? Happy Wednesday or Thursday, depending if you're Group A or Group B or distance or well, goofy. I don't know. We'll figure it out, right? So we have been talking in this. Whoa, look at that. Whoa. Sorry. I'm easily entertained. We've been talking in this unit about mixtures. And so today I want to talk about if we have things that are mixed, that are intertwined, that are either homogeneous mixtures, remember, meaning it all looks the same, or heterogeneous mixture, meaning you can see the different parts. Are there ways to separate out those mixtures? Okay, and so we're going to look at that here today. While I'm going through it, you have a note sheet. We're going to fly through it, fill it in. When we're done, we're done. Okay. So there's a few different ways we can mix them. So remember, in separate them, not mix them, excuse me. In a mixture, things are physically combined. Okay, so they're not chemically combined. There's not chemical reactions where you're bonding things together or you're changing the properties. You're just mixing them. So if mixing them is a physical action, then the separation also will be physical in nature. It'll be mixed physically and separated physically. Okay. There are actually, I got to move my face again. There are actually 1, 2, 3, 4, 5, 6, 7, 8 different methods we're going to talk about. So I'm going to show those real quick. We'll go through them. When we're done, we're done. Here we go. First one is called filtration. All right. And the base word there is just a filter, right? So think about it. If I have a heterogeneous mixture where I can see different parts, where there's chunks in essence, I can separate the solids and liquids, right? If you've ever made coffee, all right, and here's I don't know if that's if that's a cold press or if that's a hot pour, or I don't know. If you're a barista, you know what that is. I don't know. But I know the grounds are up here in the filter and they pour the hot water and, it comes through and that filter separates the grounds from the good stuff, the coffee. Filtration is just a permeable barrier. It filters. So this is like a coffee filter. You put your grounds in there, right? Put it in your coffee machine. You might not drink coffee, but you run the water through that. When you're done, you have coffee. And in here, you have a bunch of actual coffee beans, right? It filters. That's called filtration. That's the first one. Pretty straightforward. Second one is called decanting. Okay. Now, decanting is a way to separate chunks that might be in a liquid without using a filter. Sometimes you see people just pouring off. If there's a liquid and a solid, you can just pour off the top. That's called decantation. You will see that with alcohol, and I know none of you ever drink alcohol, but sometimes in wine, for example, there can be some chunks in the bottom there of the grape that's left. And so when you let it to settle, you can pour off the top part of the wine. If you take a wine bottle and shake it and then pour it out, you might get some chunks in there. Okay, so decantation is separating chunks from a liquid by allowing the solids to settle the bottom and just pouring the clear part of the liquid. Okay, that's step number 2. Step number 3 is evaporation. So there's 2 pictures on this screen. The one on the bottom right, that's where they get salt. So they're taking seawater, they put it out here, okay? And then they just let the sun evaporate the water. And if you know anything about seawater, you know it's salty. If you've ever been to the ocean, it's salty. So what's left is salt. And then people can come and gather the salt, and then we eat it. Now, look, this guy has no shoes on. He's walking in the salt. Can you imagine how bad that is for your feet there? He's probably has some tough feet. But we could take that, we can use it, not always eat it, but we use it, right? And you can do the same here. They're just taking a chemical. They're evaporating the liquid out. When we're done, we'll have whatever chemicals left in that solution, okay? So remember the words solute and solvent. When you evaporate, you remove the solvent. And then what you're left with is the solute. Right? So remember, that's when you dissolve something. Solvent dissolves the solute, salt and water. So if I remove the water, solvent, I'm left with the salt, solute. That's the third step. Next one is distillation, to distill something. Okay, you see this with making alcohol. You create a still, right? And in essence, what you do, this is to separate a homogeneous mixture. So there's no chunks. You can't take it and just run it through a filter. It'll all go through the filter. It all looks the same. So you can't just filter it. You can't just evaporate it. It's mixed up really, really well here. It all looks the same. So this one is you're looking at the different boiling points of substances that are involved. Okay. So for example, if you're making alcohol, in there inevitably is water, but in there is also alcohol. Now, alcohol boils at a much lower temperature. So if you heat it up, it's going to boil off and leave the water in the flask or the container. And so, for example, if I had water and alcohol in here and I heat it, the alcohol will evaporate and then it'll condense and run out here. And I can get alcohol out and water will stay. And that's because they have different boiling points. The water has to get much hotter to boil than the alcohol does. That's another way to separate, and that's just a homogeneous mixture. Okay, they do this with oil as well. You can take crude oil and you can heat it up. Now look at, this is a great picture. This shows the boiling parts. You can remove all sorts of different things from crude oil. So if you start with crude oil at 350 degrees, you get lubricating oil, right? At like 300 degrees, you get oil used for fuel ships. At 260, you can make gas for diesel. At 180, you can make kerosene and jet fuel engine. At 110, you can use what's called naphtha. That's a chemical. At 30, you can make gasoline for cars. So all of these different temperatures, you boil out different chemicals. And so this top picture, you see these things. This is a crude oil refinery. They're just heating it up and capturing different temperatures. Okay, pretty cool. Crystallization. This is taking a homogeneous homogeneous solution. Excuse me, a little biology at you, and creating a crystal. All right. So if you've ever had rock candy, when I was a kid, they had these rock candy. You buy it on a stick, and it just was like crystals on there. The way they do it is they take really concentrated sugar water, they dip it in there, let it sit. Okay, some crystals form, they pull it out, and then they do it again, and again, and again. So this picture here shows that's the first time it dipped, second time it's dipped, third time it's dipped, and now you got some crystals. And if that's sugar, it tastes good, and they put coloring in there, and all right. But it's a formation of a pure solute in crystal structure from a solution, so you can actually get the solid out. It takes a long time, but it can be done. Okay. Next is centrifuging. Here you can see they're putting a little vial into a centrifuge, and what that thing does is it spins, and it spins really fast, and it uses centrifugal motion. And what happens is the bigger things get to the end of the vial, the smaller things or the less dense things go to the top. And so it's called a centrifuge, and it helps to create the more dense and the less dense, the heavier and the lighter. Okay, the bigger and the smaller. You can separate all those things. The washing machine has that. When you go to before it washed all the stuff. Well, when it needs to get the water out, it spins, and the water is more dense than the clothes, so that goes to the outside and it gets drained, and the clothes stay in the inside. Okay, and that's a way to separate. All right, almost there. Magnets. Okay, you can separate things that are magnetic from things that are not. Right here, you can see in the picture, this has sugar and iron, and then they took a magnet and boop, put it in there, and here's what's left in the bottom is sugar, and all of this is iron. So you could separate that. So that's the way you could do it. And then the last one is called chromatography. Now, we are going to do this one in class. This is a little more complex. It separates mixtures based on the ability of the component to be drawn across the surface of another material. What? So this is why we're going to do this one in class, because it's a little harder to grasp. Usually it's a liquid that gets drawn across what's called chromatography paper. And we can separate things out because they travel at different rates. Some travel fast, some travel slow. It's kind of like on the highway. Some vehicles go fast, some go slow, and it's that speed of which it travels that separates it off. So we're going to do a chromatography lab in class. A did it on Monday. Group B will do it on, A did it on Wednesday, Group B will do it on Thursday, and then we'll talk about it all together on Friday. But that's another way to do a separation. So those are your different ways to separate mixtures. They're all physical. They're not chemical reactions. They're all physical reactions and ways to separate things. All right. So guys, that's all I have. Get that note sheet filled out. Click turned in. When you're done, you're done. That's all we got. Bye.